Hello students, this is Mrs. Crumpton. This is lesson 8-6 from your Glencoe Algebra 1 book, solving x squared plus bx plus c equals 0. Your learning target: I can factor trinomials of the form ax squared plus bx plus c. I can solve equations of the form x squared plus bx plus c equals 0. The key concept for this section comes from page 503 of your textbook. First off, we're going to learn how to factor a trinomial like this one, x squared plus 7x plus 12. Okay, now first I want you to look at this last term. And what we're going to do is we're going to think about the factors of 12. 1 times 12, of course. 2 times 6. 3 times 4. I want you to also note that the coefficient of the squared term here is 1. Now that is something important to note for the expressions that we're factoring right now. I want us to look also at the middle term here. The middle term is 7x. Now we're going to find factors of this last term, the constant, that when I add them together equals 7x. Okay? 1 plus 12, that is 13. So I'm not going to be interested in those factors. 2 plus 6, that equals 8. So I'm not really interested in those factors. These factors, 3 plus 4 equals 7. Now when I find the factors of the constant term, in this case 12, that I can add together and get the middle term, which in this case, the coefficient of the middle term, which in this case is 7, then I can factor this expression very quickly. Okay, so we've got x squared plus 7x plus 12. Okay, I know that 3 plus 4 equals 7. 3 times 4 equals 12. So if I factored x squared, that would be x times x. I'm simply going to take each x and group them together. Now since everything is positive, and that's something else important to note, the signs for both binomials, the signs inside are going to be positive, and I'm going to take one of each of those numbers that we said we can multiply together and get 12. We can add together and get 7. And I'm going to I'm going to write those in to our binomial groupings. And guess what? That is how we factor these type of trinomial expressions. It's pretty easy. Look back over it, make sure you understand each step, and if you don't, be sure you write this problem down, bring it to class so we can discuss it further. Let's look at one more example of problems like this where my terms are not all positive. Okay, this time I've got x squared minus 12x plus 27. Okay, now think about what I did just a minute ago. I want to look at the constant term. In this case, it's 27. Let's write out our factors of that constant term. 1 times 27 and 3 times 9. Okay, now I want to look at the coefficient of the middle term, and we have a negative 12. Alright, so let's think about this for just a minute. 1 plus 27 is 28. If I changed both of those to negatives, that would be negative 28. Since this term in the middle is positive, since the term in the middle is negative, the term on the end is positive, our constant term. I want to be thinking, what terms can I multiply together, including their signs, that gives me a positive, but when I add them together is going to give me a negative? Okay, let's think about that. 3 times a negative 9, that would give me a negative 27. Negative 3 times 9, we don't need that parenthesis there. Negative 3 times 9, and I'm saying 9, but writing 3. That equals negative 27. Well, how about negative 3 times a negative 9? Well, that equals a positive 27. Okay, so let's consider the factors this way. And what does negative 3 plus a negative 9 equal? That equals a negative 12. So these are the factors that I'm going to use, except I'm going to use negatives. Okay? Remember just a minute ago, the previous problem that we did, we had x squared minus 12x plus 27. We know the factors I'm going to use here are negative 3 times a negative 9. I know that x times x gives me x squared. So, to factor this into binomials, two binomials, get my parentheses ready. I'm going to take 1x, and I'm going to take the minus 3 and the minus 9, and that gives me my factored form. Now, if you want to double check yourself on these, just to make sure that you're factoring correctly, you can multiply these back out using either the FOIL method, distributive property method, or the Punnett square method, just to make sure you get what you started with. If you get what you started with, then you know you've factored it correctly. Okay, students, let's look at another example. This time, I want you to note that the last term is negative, the middle term is positive. So let's look at the factors of 18. 1 times 18, 2 times 9, 3 times 6. Are there any other factors? I think we got them all. Okay, now this time I have a negative and a positive. So I know that a negative times a positive would give me a negative. Okay, with the middle term being positive, this tells you that the larger factor or the absolute value of the larger factor is positive. So let's look at our factors and think subtracting this time. Which two factors, when I subtract them, give me a positive 3? Alright, and the larger factor being positive. 18 minus 1, well, that's 17. 9 minus 2, that won't work because that's 6. But 6 minus 3 does work because that is a positive 3. Okay, so let's go back to our problem. X squared plus 3x minus 18. Okay, and the factors that I'm using for that minus 18 or negative 18 is negative 3 times 6. I've got x times x here. I know that negative 3 plus 6 would give me that 3x, or the coefficient 3. So all I've got to do here is group two binomial terms together, x minus 3 and x plus 6. Okay, and again, you can FOIL this. You can use distributive property, or you can use your Punnett square. And as long as you multiply this back out and you get the same thing, then you know you have factored correctly. The ones with the coefficient, the problems, expressions in the form ax squared, x squared plus bx plus c, where the coefficient is 1 in front of the squared term, they're going to be this easy every single time you do them. Okay, your next example, I want you to notice the signs again of the terms. I've got a negative here. I've got a negative here. All right, so let's think about our factors of 20. 1 times 20, 2 times 10, 4 times 5. Is there some combination of those factors that when I add or subtract them, that they would give me the coefficient of the middle term, which here is a negative 1. Just a reminder, the expressions that we're looking at right now, the x squared term has a coefficient of 1. Okay, now I know that in order to get a negative for that constant term, I've got to be multiplying a negative times a positive. Okay, so this middle term, the coefficient of the middle term, tells me that the larger number, or the absolute value of the larger number, or I'm sorry, I said that wrong. When I subtract these numbers, the larger number will take the negative. Okay, so let's start with negative 20 plus 1, and that's negative 19. Okay, that doesn't work. Negative 10 plus 2, that gives us negative 8. Negative 5 plus 4. Look what we got. That gives us a negative 1. So that is the combination of factors that we're going to use. So let's rewrite our problem. X squared minus x minus 20. Okay, now we said since the negative, the coefficient of the middle term is negative, our larger factor is going to be negative. So here we're going to have a negative 5 times 4. Of course, this is x times x. Now you group your binomials together. We've got x's minus 5 plus 4. Okay, students, now you can FOIL this, you can distribute, or you can use your Punnett square and determine, have we factored this correctly? Take a look at this problem again. If you've got any questions, be sure you bring those questions to class. Now we're going to solve a quadratic equation. Now we've talked a little bit about quadratics, and I've told you that that's the direction. Okay, the direction that we're going is to solve quadratic equations. All right, so let's take a look at this one. We're asked to solve x squared plus 2x equals 15, and check your solution. So let's rewrite that. X squared plus 2x equals 15. Now I want you to look at the form in the definition. Ax squared plus bx plus c equals 0. Now is the equation in that form? I hope you said no. All we've got to do to get our equation in that form of a quadratic is subtract that 15 from both sides. However, pay close attention that the 15 is not a like term for the x squared or the 2x. So I don't want to subtract it from either of those terms. But we do include it just there to the side. Okay. Now we're going to use the same method that we did just a few minutes ago to solve this equation. We want to think about our factors of negative 15. Okay, 1 times 15 and 3 times 5. Okay, now our middle term is positive. So let's go with the larger term being positive. 15 minus 1, that's 14, so that's not going to work. 5 minus 3, that gives me positive 2. So those are the two terms that we're going to use to factor and to solve this equation. Okay, of course we know x squared is x times x, and we just saw that we are going to use 5 times 3, and of course we know that gives us our positive 2x. So to factor this equation, we factor it x plus, and I forgot my negative sign there, x plus 5, x minus 3 equals 0. Okay, now I'm going to erase a little bit of this so I've got a little bit more room to write and not have to go to a separate slide where you don't have all of these notes. Okay, let's, now we're going to take and separate, like we did in the previous section, each of these binomials, x plus 5, set it equal to 0, and x minus 3, and set that equal to 0. We're solving two one-step equations. Solving the first equation, I'm going to subtract 5 from both sides, and we've got x equals negative 5. I'm going to add 3 to both sides, and x equals 3. So our two solutions here should be x equals negative 5 or x equals 3, or and x equals 3. Now our directions also say to check your solution. I'm going to leave that to you. I want you to go back and substitute negative 5 in, then work the problem again, substitute 3 in, see if you get 0 both times. Our next example, Ms. Gibbons wants to build a new dance studio that has 3 times the area of her old studio by increasing the length and width of the old studio by the same amount. What would be the dimensions of the new studio? Okay, now let's think that through a minute. We've got the old studio. To find the area of that old studio, of course you know the area of a rectangle is length times width. So the area of the old studio is 120 feet squared. Okay, now it says that we're going to increase the new dance studio by 3 times. So our new dance studio is the area is 3 times the old area. So that's going to be 120 times 3, or 3 times 120. So the area of the new studio is going to be 360 feet squared. Okay, go ahead and make sure you write this down. I'm going to need to erase that in just a second. Okay, students, back to our problem now. Mrs. Gibbons wants to build a new dance studio that has 3 times the area of her old studio by increasing the length and the width of the old studio by the same amount. What should the dimensions of the new what should be the dimensions of the new studio. Okay? So we have our area of the old studio was 120 feet. The area of the new studio is 360 feet. So what we're going to be doing here is solving an equation to figure out the dimensions of the new studio. Okay, the new studio, she's adding the same to both the length and the width. So we're adding X amount plus the original amount, which is 12 feet, to the length, and we are adding X amount to the 10 feet that already exist, and that is going to give the 360 feet squared, or square feet, whichever way you say that, to the new studio. Okay, now look at what I did. We've got the existing studio plus what's going to be added on. We have our existing studio plus what's going to be added on, set up into binomial terms that we're going to multiply together. Why do we multiply those? Area equals length times width. That's why we multiply those. And if we knew what X is, or X is going to be, then we could figure out the amount of each. Alright, students, so what we're going to have to do is we're going to have to either use distributive property or the FOIL method to multiply these binomials. So we will have, I'm going to take a shortcut here and do that. We would have x squared plus 22x plus 120 equals 360. Oops. 360. Okay, now remember that form of a quadratic equation. Ax squared plus bx plus c equals 0. So since I don't have this equation equaling 0, I've got to subtract the 360 from both sides. Okay, so now we have x squared plus 22x minus 240 equals 0. Now this is going to be the same procedure that we did with the previous problems. We're going to look at our factors for 240, and is there some combination of those factors that will give me that middle term of a positive 22. Well, I'm going to kind of take a shortcut here. I know that 8 times 3 would give me 24. So I know also that 8 times 30 would give me 240. Now I need to determine which number is going to be positive, the 8 or the 30. And we do that by looking at the middle term here. Since the middle term is positive, that larger number is going to be positive. So we're going to have x times x, and over here we're factoring 30 times a negative 8. And of course, when I added those together, that would give me the 22. So I'll have x plus 30 times x minus 8 equals 0. So now I need to solve both of these equations set both of these binomials equal to 0 and solve. Okay, and when I set these equal to 0, I've got x plus 30 equals 0, x minus 8 equals 0. To solve, I subtract 30 from both sides, and I get x equals negative 30. I add 8 to both sides for the other binomial, and I get that x equals 8. Alright, now think about this for just a minute. We're talking about measurements here. We're talking about feet. It says, what are the new dimensions of the studio? Okay, now does it make sense for one that I'm adding a negative 30? No, that does not. That means I'd be making the studio smaller, and I can't do that. That's not what my goal was. My goal was to increase it. Okay, so my original length was 12 plus x for the new studio. So if I replace x with 8, 12 plus 8 equals 20. My width was 10 plus x, or I think I wrote it x plus 10 originally. If I replace x with 8, I get that the dimensions would be 18. So Miss Given's new dance studio is going to be 18 feet by 20 feet. There is your answer. Now be sure if you have questions about this problem or any problem in the lesson that you write down these questions and bring them to class so you can ask me. Now students, we're down to our formative assessment and what will be your classroom assignment. Just to get you a little bit of practice on these to get you feeling comfortable, I would like for you to try 1, 3, 9, and 11 from page 507. That's your formative assessment. Your classroom assignment, which if you feel comfortable enough and you'd like to go ahead and start, page 507 and page 508, 12 through 16, 20 through 23, 31, 33, and 41. Thanks so much for listening and watching the video, and I will see you in class.